So our bell ringer for 10.4 is our tangent ratios, is our topic today. But we're going to do this warm up. So here on this picture, we see that 5 is on the side between 60 and the right angle. Which side does that correspond to on our 30, 60, 90 formula triangle? Yeah? Okay, so let's re-ask that question. So if you're in the middle of having a conversation, you're stopping it. You see here, we have the 5 that's in between the 60 and the right angle, so the 90 degrees. Which side corresponds to that on this triangle? It's just x, right? So we know our value of x in the first triangle is 5. So x equals 5. Now that we have that, we can now find our other two remaining sides, and I'm going to make you do both of them, even though I didn't put one here, by now putting those formulas up there. So I gave them to you in terms of x up here. Our worksheet for the review did them in terms of a. So in terms of x, what is our side that is the 30 to the 90? What is that length in our formula triangle? X square root of 3, yep. And our hypotenuse is 2x, right? So now that we have our x, I'm able to solve that by substituting in. So my value of x was 5. So this becomes 5 square root of 3.
Hold on.
Now we have 2x, which is going to be 2 times 5, which is 10. On our next one, which side length do we have if we have 18? Which one does that correspond to on this one? Yep, so we know that 18 on the formula triangle is that x square root of 3. With that, we now want to solve for x. So we have to isolate that. I'm able to divide by the square root of 3. I ended up with x equals 18 over the square root of 3. We can't have a radical in the denominator. I think Jalen was just saying this. Maybe I'm just thinking I'm hearing it. So what do we do? I thought you said divide.
Oh, yeah, I did.
Yeah, we're multiplying, and we're going to be, or the same thing as dividing by the square root of 3 over, 1 over the square root of 3, which is going to be the square root of 3 over square root of 3. Now we created the square root of 9 in the denominator, and on top we have 18 square root of 3. What is the square root of 9?
3.
Yep. This becomes a 3. 3 goes into 18 how many times?
6.
So let me switch back to a different color. Goes into it 6 times. So now I have x equals 6 square root of 3. Okay, so the value of x on our formula triangle is the one between 60 and the right angle, which in this case is actually the value of x here. So we know that this has to be 6 square root of 3. Our hypotenuse, I know I didn't ask for it, but we're still going to do it, has the value of 2x. So it's going to be 2 times the x value you just found. So what is 2 times 6 root 3? You're so close. You doubled it. You did 6 times 6.
12 times.
So 12 square root of 3. You were really close.
Oh.
You squared instead of multiplied by 2. Okay, and then our last one. Which side length do we have here again? The x, the 2x, or the x root 3? You have the x, right? So that means that our actual value of this side length is going to be x root 3. And we know that would be 7 square root of 3. And we know our hypotenuse is 2x, which is going to be 2 times 7, which is 14. Today we are talking about trigonometric ratios. The definition of that is written at the top. A ratio of the lengths of two sides of a right triangle. The key part here is a right triangle. We still are talking today specifically about tangent. We usually abbreviate that with tan. And we use this and we find tangent by opposite over adjacent. I'm going to fill in this triangle in a minute, but I'm going to give you a second to write down what you need to on this slide. So tangent is opposite over adjacent. So if we were going to find tangent, so tan of theta equals the side opposite of theta, which is AB, over the side adjacent. So remember we talked about adjacent angles. They were angles that lie next to each other.
Question.
So this is going to be AC. Yes, ma'am.
What is this for?
Find the tangent of angle A, then find the degrees of angle A to the nearest tenth of a degree. So we have tangent of A is what we're finding. So we have tan theta. Well, actually, I don't want to put theta. Tan of A, because A is our angle. Remember, we're talking about angles. It's a capital letter. So tan A equals, and we're writing out the ratio that goes with this. So opposite. So what is opposite of A? So the side that is going to be opposite is going to be the one that corresponds with that 6. So it would be BC if there was actually a C here. So it'd be 6 over the one next to it, which is the adjacent, which is 8. Nice job. So if you're using a calculator, you hit second tangent. Your tangent now has that -1 exponent. It's the TAN button. And then you're going to put in the fraction that you have. Our fraction we have here is 6 over 8, or that is can be reduced to 3 over 4.
You said per second?
Yep, so you're right. Yep.
And put what?
And then you'll end up with on your screen tan inverse of 3 over 4.
I think I got 23.
So what did you get?
36.9.
0.9.
You got to round it.
Okay, so again, we're looking at tangent of A. I'm going to change my color so you guys know where we're at. So we have tan of A equals, the side opposite of A is 12. The side adjacent to A is 5. So now when we go to put this in our calculator, we hit second tangent, which is tan inverse of 12 over 5. Which is going to be 57.3. 67? Okay. So let's walk through the steps. So you have tangent of A equals, so that's going to be opposite, which is
40.
over.
9.
Okay, then you have tan inverse of 40 over 9, which is what?
77.3.
Do you guys agree?
Yes.
77.3 degrees. So on each of these, we put a degree symbol. So remember what that looks like from your previous math classes? Degree symbol, degree symbol, degree symbol.
Points to the
So for our next 4, 5, and 6, we have to do the ones from the previous slide, but solve for B. So now we have tangent of B. So tan B equals, and now it's opposite of B, which is opposite of B, over 6.
I thought the opposite of B was 8.
It is. It's 8. And then the one next to...
8.
So this should have a C here, so it would be AC. And then the opposite of, or adjacent to B would be BC.
So how we know to use the B? Where is it find B?
So now we're finding B. So when we put this in our calculator, you have tan inverse of 8 over 6. So B equals what value? So 53.1. Okay. In question number 2, we want to find tan B. Tan B equals, what's opposite of B? 5. Next to B is 12, which brings me to tan inverse of 5 over 12. 22.6. Do you guys agree? Okay. And then last but not least, we want to find tan of B for 3, which is opposite 9 over
12.7.
12.7. Okay, so when you saw that the other one was 36.9 and this is 53.1, what do they equal?
90.
They equal 90. If we looked at number 2 and you found A and you add it to our what we got when we found B, it's going to equal 90. And we do the same thing with 3, they're going to equal 90. These are complements of each other. So we see this time things are going to work a little different. We are going to be given the angle measure and a side, and then we have to find the missing side. So what goes in your blank is angle measure. Another one is one side, and then we'll have to find another side. So your blanks are angle, 1, and side.
I got it from my bed.
So yes, just set up and the same cross product and solve. So the blanks here are cross product and solve. So finding the side lengths and then we're rounding it to the nearest 10th. We're still using tangent, but now we know the angle. So we have tan. What is my angle in this case? 42 degrees, right? So remember that theta is going to be a degree. And so in this case, we actually have the 42. So what side is opposite of the 42? 12. What side's adjacent? X. Now we want to solve for x. So previously when we were solving for angles, we needed to use tan inverse. This case, we're not going to. We want to get x by itself. How do I move x to the other side? Yep, I'm going to multiply each side by x. So now I have x tan of 42 degrees equals 12. Hey, I still want to get x by itself, but now I have it being multiplied by tangent. How do I get rid of it now? I've got to divide it out. So I'm going to divide each side by tan of 42 degrees. Okay, so now what you're going to put in your calculator is going to read x equals 12 divided by tangent of 42 degrees, close parenthesis. So when you do that, you're going to get x equals 13.3. So we're going to start with tangent of 34 degrees, that's the angle we have, equals opposite, which is all over x. It's a similar setup. Now we want to get x by itself. Just said, we're going to hit multiply each side by x. Tan of 3, 4 equals 7. We need to get that to the other side. Tan of 34 degrees. Tan of 34 degrees. X, can you see this still? Equals 7 divided by tangent of 34.
It's 10.4.
10.4, do you guys agree?
Yes.
I say no more.
You second it?
Okay, so we have tangent of our angle, which is 55. So tangent of 55. Tangent is?
12.6.
It's going to be opposite, which is?
Oh, with the 18.
Over.
Oh, it is.
Okay, we want to get these on the same side. You multiply each side by x. You end up with x tan
So 18
of 55
don't go first.
equals 18. Okay, what's your... So now we've got divide over by the 18.
So whatever number inside the thing, that's the tangent.
So whatever the angle is goes what's inside the tangent.
So the number inside the triangle.
Yep. So you said it was 12.6?
Mm-hmm.
12.6. These are side lengths, so they are not degrees, they're side lengths. You forgot your division symbol. Okay, and our last one, hold on.
You're like a lawyer.
I have a tangent of 62 degrees. So tangent of 62 degrees is going to be opposite, which is over 12. This one's different. Last two times x has been in the denominator. Now we want to get x by itself. How do I get x by itself? I multiply both sides by 12. Excellent. So now I have x equals 12 tan of 62.
It's 5.3. No.
Okay, so I have two different people shouting out answers.
Oh,
It's
6.4.
6.4. I get 0.3. It's
So for our last one, we did division on accident. So when you multiply it out, it ends up being 22.6.
Hey, Brittany.